So what do we know right now? We know that prefix codes are uniquely decodable. But not all uniquely decodable codes are prefix codes. Now, unique decodability is all that I need in order to have a good source code. So remember I said this last time, that if a source code, the very minimum that you need for a source code is that it needs to be uniquely decodable. If it's not uniquely decodable, then you can't map a certain received vector into a unique string of source symbols, and so therefore your code will fail. Prefix codes have an extra desirable property, which is instantaneous decodability. That property is good for complexity, but is not necessarily required in order for it to be a good source code. So the question that I want to ask now, we know for prefix codes that L of C has to be greater than or equal to entropy. So the set of prefix codes is smaller, so this suggests that the set of prefix codes is smaller than the set of uniquely decodable codes. Because prefix codes are uniquely decodable, but not necessarily vice versa. So there are codes in this set that are not prefix codes, and my question is, these are good source codes, they're uniquely decodable, so they work well as source codes. Do there exist uniquely decodable codes with h of x larger than L of c? In other words, if we abandon prefix codes, can we get below the entropy? Now, intuitively, the answer should be no. If we think back to typical sets, we talked about how source coding would work with typical sets. We could construct an argument saying that there does not exist a source code with probability of error approaching 0 that has a rate lower than the entropy, but or an average encoding length lower than the entropy, because that would violate some of the properties of typical sets that we talked about a while ago. That's not the approach we're going to use, however. Well, but let's actually stop for a second and think about the intuition there. We know that if we were to approach this question from typical sets, we would say that the number of bits I need to encode the typical set is, well, how many code words are there in the typical set? It's 2 to the n h of x. Remember. So the number of bits that I need in a source code is log of that, which is n h of x. So therefore, in order to cover the entire typical set, I need at least this many bits. So if I attempt to use fewer than that, then it must be true that I'm missing some code words. And if I miss any part of the typical set, remember all the code words in the typical set have approximately the same probability. So it's not as though I can just miss the low probability part of the typical set. All of the elements of the typical set are needed. So therefore, I really can't get away with less than nh of x. I'm actually going to take a different approach here. The answer to this question is no. Intuitively, it's no because of the typical set property. We could make that more rigorous if we wanted to, but the way I'm actually going to show it is to say that all uniquely decodable codes satisfy the Kraft inequality. That's actually a little bit surprising. So the Kraft inequality shows us how to construct prefix codes on trees. And actually, we started out by saying if you have a prefix code, you can put it on a tree. And then we said, because of the way that descendants are knocked out of this tree by the prefix property, it must be true that the Kraft inequality is satisfied. But it turns out that no, any uniquely decodable code must satisfy the Kraft inequality. So let's prove that.